Hey, this is Ajinkya, and you're watching JS Funk. We are going to start with a series on Golang. This is more like an episode based videos, kind of like just for funk. And in today's video, we are going to start creating a web crawler. So, if you're wondering what's a web crawler, it's a kind of a part of a search engine that scans web pages looking for links and then follows them. It would normally store this found URLs into some database. Our version is just going to scan through the URLs and print them on the screen. While it's not going to be quite an enterprise grade application, but we will deal with some of the basic concepts and see some satisfying result gets printed on our screen. And let's get started with creating our project now. So I'm at my src folder. If you're wondering how did I come up with this path, make sure to watch the installation link in the description. So make sure you have proper golang setup on your machine, and as well make sure you have the latest version of go, because we are going to use go mod, which is available to you only after 1.12. So I'm going to create a directory over here called, inside this directory we have nothing. I'm just simply going to create a main.go file. Okay, and this is going to initialize git so that I'll be able to share this code afterwards. And I'm going to introduce go mod over here. So of course go mod has to have an init method when we are starting it for the first time. And as you can see, now we have three files over here, two files over here, main.go and go.mod. And once we add few of the external packages, you have to run go.test. We'll see that later on. And this go.mod file creates a file called go.sum, which is kind of like a security file. I'm also not exactly sure what it is for. I'm also a beginning into Golang. I'm kind of a gopher starting out just now. So please feel free to post in the comments. So let's get started by opening our project into Visual Studio Code. Basic file in Go is like a main.go, which has to have a package name, package main, and it has to have a function called func main, right? And func stands for function. Okay, let's just print out an hello world. Okay, and let's just run this code into our terminal. Okay, everything is fine so far. So what we're going to use is we are going to use an HTTP package from Go team, and we are going to provide it with a basic URL. So basically, HTTP dot get will get us an HTML page. So we are going to pass it an URL over here. So let's just define that base URL over here first of all. For now it is going to be an HTTP URL. And if you notice, okay, we are just running this, but if you hover on the get, you will notice that it has a return type. So this defines the return type of our function. So it is going to return us two variables, and we are going to use the Golang's destructuring over here. So this is kind of like a variable destructuring. So we are going to get a response and we are going to get an error. Okay, handling error in Go is really simple. So you just check with an if condition. If error is not equals to nil, then we do something with that. Okay, so in our case we are just going to do an fmt.println. So we are just going to print out that error to the screen, and we are going to exit from our terminal, right? And that's going to say exit 1. Okay, so far I think we are going to deal with errors few or multiple times. I'm just going to create an easy function over here called check error, which is this, and which accepts an error, which is a type of error. Okay, type of error is already defined into golang, and we are going to reuse this func check error over here like this, and we are going to pass the error over here. All right, so far so good, and I'm just going to reduce this height. Okay, yeah, perfect. So we have this HTTP response, and let's just print it to the screen. So I'm just going to say fmt dot println and print the response to the screen. Let's see what we get. Okay, so let's just run main.go. Allow this is my firewall. Okay, so it is reading out an entire page and it is giving us something, right? So this is like a big HTTP object that we are receiving. You might also get an error since YouTube is an HTTPS page, right? Let's try that now. Since we are on localhost, we might not get, but let's try. Okay, so far so good. HTTP status okay. Okay, now if I just say response dot body, let's see what we get. Okay, so this is the object that we are receiving. So response.body is an IO reader. So if you roll over on body, you will see it is a type of IO.reader, and it has to be closed afterwards. But now when I mentioned response.body needs, it's not a string, right? It's more like a reference to a stream of data. So we are going to use IOUtil package from Go, and we'll store it into our memory. So let's just do that first. So I'm just going to say body and error is equal to IOUtil, okay, dot read all. Okay, read all method stores everything into the RAM memory of your machine. So I'm going to pass response dot body over here, and this body needs to be closed. So we are going to close it at the end of our function. So I'm going to say body dot close. Okay, like this, and this will just simply print out something over here. Okay, and we're just going to say fmt.print body, and let's see if this works. Go run main.go. Okay, body.close is undefined. What I forgot to do was we have to close this guy, not the main guy. Okay, so this body is not from the response, but this body is a byte of an array. Okay, so you'll see that now. Okay, so this is what I meant by byte of an array. So we are receiving all the body into byte array. So we need to convert this to a string. But also before that, I'm just going to ignore this error. So, or otherwise you can just simply do an error check over here for this error. But in case if you want to ignore this error, you can simply say underscore, which will ignore that error for us. Okay, and let's just try to run this again. And you can see this is the exact HTML that we are receiving. You can see we have a lot of URLs over here. Okay, and this is a big HTML file, and this is what we are receiving from this URL from http.get. Also, I mentioned earlier that if you try to read an HTTPS URL, so what I mean by that is if you host this code as a service over the internet, you would face an issue, because if you try to access an HTTPS URL, this HTTP client will give you an error. So I'm going to use my own HTTP client, and I'm going to say simply ignore the SSL certificates, right? So let's just do that. So what I'm going to do is I'm going to create a new variable over here called client. Okay, and a client is going to be http is going to be a pointer to http client. Okay, an http client has many things. So one of them is transport. So transport is basically lets us modify the http client, the original http client. So we are just going to modifying the transport part of it. So I'm just going to create another variable over here called transport, which is going to be a type of http transport. I'm not sure, let me check. Yeah, it is a type of transport. It's going to pass again and represents an address. It's kind of a pointer to the http. um, Explanation about pointers will be in future videos. http.transport, which expects so again transport has many methods, but the one which we are interested is the TLS client config. So I'm just going to add that over here, and the config is a variable that we are going to create now. Okay, config is again going to be a TLS config object. Okay, and again TLS config has many options, but the one of the option that we are interested is into insecure skip verify. Okay, I just knew about the starting keywords, but since I'm using VS Code, it has IntelliSense and it is giving me the right keywords. Okay, and I'm just going to say insecure skip verify to true. Okay, I'm just we are just going to skip the SSL. Okay, so since I want this client to be reusable, okay, I'm going to declare it at the top, but afterwards. And as well, let's just combine these imports together. So I'm just quickly going to combine them. This is how you combine the imports. And so we have a client which we created. Now we just need to pass this transport. All right, perfect. So I'm just going to use this client instead of our http.get. I'm going to call this as net client.get base URL. Okay, so far so good. We have created a basic client. We have added a basic error handling. Then we are reading all the body parts from the response. Uh, the main thing which is remaining now is extract all the http links, or I should say extract all the anchor links from this body. Okay, to extract those anchor links, Go has a package called html, not the http, html. It's on xhtml. Yeah, this one. So if you land upon xnet html, over here you will see we have something called, yes, html.parse, and it needs a reader. Okay, and once you have this reader, you have to follow this for loop. When you pass the reader object that you have passed via this html.parse method, it returns you a tree structure of the DOM, and you have to traverse with the for loop of that tree structure, and you have to keep finding the anchor tags, extracting the href and text attributes from it. In most languages it is not fun, uh, and I would say in Go as well it's not fun. So I have extracted out a simple package called extract links, which does the same thing, and we are going to do just that. We are going to use this simple package extract links. For now we'll just use this, and in future videos I will have a series, I will have a video on how I created this extract link package. But for now let's just add that to our project. To add a package, you have to say go get, and we need the latest version of it, and I'll just simply paste the URL over here, which would add it to the library. And we are using the latest of this extract links, which should be 0.0.1. And now if you look at this, we have automatically created a go sum file over here, and if you look at the go mod file, it has added this version over here. Okay, now to use this package, you simply go to the imports and add it like this, extract links. And now this extract link is available to us as an extract linked variable. So I'm simply going to say, instead of using this IOUtil, I'm going to use extract links dot all. So it has this method. It takes a reader object, which is this response dot body. Okay, and once we pass this, we get all the links over here. Okay, and this links also has an error. We'll just deal with that error like this, simple error. And let's just print out what are those links now. I'm simply going to print them out to the screen. Okay, and also one more thing I forgot to mention, rather than adding this response.body dot close at the end, you can as well do something like this. So you already know that you have this response.body, right, which you got it from over here. So you can simply say defer response.body.close. So it's another way of saying wait. So defer is like way of saying wait till the end of the execution, and at the end till this function exits, and then you run this function. Okay, so now I'm just going to move this after error. Okay, we are using extract links.all. Let's see on screen how it looks. So I'm just going to say go run main.go. So it is returning us a huge object, right? So this object is more like a so you are receiving so many URLs from this current page. So it is also returning you the path of the URLs. So if you look at the browser now, any of these side links, okay, you can see at the bottom of the screen over here, when I roll over, I'm getting to see those links. Okay, and we have this movies, gaming, premium, live, okay, fashion. So all these links are available over here. Okay, and that is what this extract link is doing. It is just simply reading only one page at a time and giving you all the links back to you. Okay, but what I want is let's just print them one by one. So to print them one by one, we're simply going to loop through it, get the index, then we have this link which is coming to us from a range object. Okay, so I'll just use this fmt print. We'll say index, instead of println, I'm going to say printf. So index is percentage value, then link is this link. So I'll just say percentage value again over here, and let's just pass them I and then the link dot href. All right, and as well at the end, let's just say /n for the new line, and let's see it in action. Okay, so this is what we are receiving. And if you look at this link object, it has a text node as well. I'm just going to print it out over here. Let's see how it looks. Okay, so we are receiving href and we are receiving a text. And if you notice, I did this plus over here, which is kind of like a give me more details. I'm not completely not sure, but it works every time. So far, what we have done is we have our custom transport with the net client, and we are doing the get for the URL, and we have this extract all links. But the missing things is, first of all, we need to get this URL from arguments. Secondly, we have to move this part into its separate function. And the third part is, once we extract out all the links, we have to visit each of those extracted links again. Okay, so let's see how we are going to do that. First of all, let's just get this base href from the command line arguments. So what I'm going to do is, I'm just simply going to use the os args. So that is args, or I'll just say arguments is equal to os.args. All right, so once we have access to the os arguments, let's just print them out to see what we are receiving, and just check it out. Print ln args, and let's just pass the arguments and see what we are receiving now. So arguments we are receiving are where the current directory from where you are calling this till here, and the argument. So basically what we are interested is, we are interested after the index 1. Okay, so the easiest way to getting that from this array is, we want everything after the first. Okay, and this is how we get it, and we are just simply going to output this again. All right, so as already you can see, we are getting the correct arguments. So let's just simply do a check over here. If length of arguments is equal to 0, then we throw an error. So we just tell the user, hey, that you're missing certain arguments. As well, we have to exit it over here. So we'll just say os.exit and say 1. Okay, so I think I'll just call this as base URL and not the arguments, because this is what the argument is going to look like. And just check it out over here. Just for the sake of displaying it on the screen, we'll just say println and base URL. All right, so cannot use base URL as type of string, blah blah blah. So basically the net is having an error now because this is not a new URL. So let's just pass it a correct URL over here. Cannot use base URL type of string as an argument. Okay, let's see what we are getting over here. I think you must have already spotted this. I did a silly mistake over here. So arguments is basically an array, still an array, and we have to get the base URL from the arguments 0. All right, and so this arguments is something like this, and now we should have the correct base URL. Let's try to do that again. All right, the base URL is correct, and that's it. So this works. So now let's just create our function to separate this code into a different function. So I'm just going to call this as func crawl URL, okay, and which accepts an href, and it's going to be a string. All right, so I'm just quickly going to move this into our crawl URL, and I'm going to remove this part. All right, so now the net client is not available. As you can see, the crawl is trying to access net client while net client is declared inside main. So we need to move this variables outside. Okay, and I'm just quickly going to turn them into variables. So we have now globally declared variables which should be available to us now. and href is the part which is going to be getting crawled every time. And what we can do is we can just simply print out over here fmt.println or printf crawling url and %v and just display the href that which we are crawling. All right, and also add a /n for a new line. So far we have a crawl function which crawls to the URL given, and once we crawl to the URL it fetches the HTML. Once we have the HTML, we are extracting all the links from that HTML body. Once we have all the links from that given URL, then we get the body and we have all the links. All right, so again we have to crawl all these URLs, right? So eventually what we are going to do is we are going to call the crawl function again, right? But doing a for loop over, doing this inside this for loop, and again trying to call this function over here and just passing this link would not make sense. So basically what I'm trying to do over here is link.href. So if you look at this, we are simply calling this crawl function, which is going to be from here. All right, this is the starting URL, and we are calling this crawl function, which is getting stuck over here. Let's see if this works and we'll know if we are doing any mistake. Okay, let's see what is this speaker problem. Okay, I'll just quickly rename this to crawl URL. All right, let's try to run this into our terminal. Okay, so now what is the problem that we are facing over here is we are crawling this, but after this crawling, as you might have seen before, we also have certain URLs which are just path, which doesn't have the information about the host. So some of these URLs they are something like this. So they are slash, so they can be a /, they can be a / with some path, right? But some of them have the correct information like http, then your youtube.com / some video link. But this part, the host part, that is what we need to append over here. So how we are going to do that is we are going to write a new function over here. And as well, this is not a good idea to loop through the crawling, which is not efficient, and we'll fix that afterwards. But first let's fix the URL. And so what I'm going to do is I'm going to create a new function over here called toFixed URL, okay, which accepts the href that we need to fix and the base URL, right? So these are both going to be strings. So if this href doesn't have the host, then we are going to take the host information from the base URL. Okay. So we also have a new package URL parser from Go team, which we can use. Okay, net URL, and it has a method called parse. So as you can see, we are going to pass a raw URL which returns us a URL object. And if you look at this URL, it has everything, all the information that we need. Okay, so let's try to do that. So what I'm going to do is I'm going to create a new variable over here, URI, and an error, because URL package also returns an error as a second argument. And we are going to pass the raw URL over here, href, and if error is not equals to nil, So in this case, if we have an error, we just simply return an empty string. We have no option. Okay, also define a return type. Okay, and as well we have to create the object from the base URL. So in this case, I'm just going to say base and going to pass base URL. All right, same thing. If we have any error, we are simply going to return empty. Okay, so far we have URI object and we have a base object, which is a type of URL struct. Okay, so we need to return the joined URL, right? If you inspect over here, the URL println, what I did was just went ahead URI host and base URI host. Just it will just print some nice console log. Okay, nice prints. And let's just try to run this. Okay, so now as you can see, the URI host is empty. The URI host is empty, and if you look at the base host, it is js.org. Okay, I just went ahead and changed the host. Okay, but so far we have identified the cause. The URI doesn't have the host. So what we can do is we can take the host from the base and use the path from the URI. We can simply go ahead and fix that. So what I'm going to do is I'm going to call a new function over here, called new method over here from the base, which is going to be resolve reference. So it takes a complete URL object, which is in our case is the URI, and it will return us a new object, which is again a URL object to fixed URI. And what this is doing actually is it is taking the host from, so it is taking the host from base and it is taking the path from URI. Okay, if URI has its own host, then it will simply use the host from URI. Otherwise, what it will create is it will take base host plus URI path, and that is what is being returned over here. And now if we if we call this toFixed over here, toFixed.string, it will fix the URL for us, and that's it. And let's just try to run this again. Okay, now you can see this was the initial crawling URL. I think it is still not fixed. Let's see why. Okay, we forgot to pass this function to the crawl. So we are simply going to remove this and pass the fixed URL. And let's try to run this again. And now you would see that we are crawling correct URLs, but now we are stuck in an infinite loop. So what this infinite loop is basically we are crawling through the URL, we are crawling through the page, but again we are not queuing up them right. So we are going to fix that with concurrency. So basically, to avoid this issue, we need to keep some kind of queue where we would put the links that we found in the back of the queue, and we visit the page that is in the front of the queue, right? And we can fix this with channels and concurrency. So concurrency is available in Go with just a Go keyword, but let's just create a first channel. And let's see what this guy's crying. Okay, yeah. URI. It needs capital. I don't know why, but yeah. This should fix this. And let's just create a global variable over here called Q, which is going to be a channel. It's a channel of string. And this Q, which is a channel now, is going to receive the base URL initially as a concurrent function. So go So we are just going to run a function over here, okay, which is going to be an anonymous function right now. So the queue receives its base URL. In this case is just the argument 0, where we can remove this. And once the queue receives this, we have to execute this function as well, right? But this function is going to be concurrent. Okay, so we need to keep this concurrence. So what I mean by this concurrency is we need to keep this function asynchronous. Otherwise, we would exhaust all our resources ever visiting a single link, right? So as soon as we receive this, we are going to whenever we receive a URL, we are going to crawl that. Okay, so that is what this is going to help us with that. I know my explanation might not be perfect, but yeah, that is what I'm going to explain right now. Okay, so let's just loop over the for loop. And so we have to loop over the range of the queue, and from the range we are going to receive an href, and we are just going to pass that href over here, right? And this href is going to be passed over here. Perfect. So we have a basic queue ready. We are crawling from the queue of the URLs or hrefs. Once we have the href, we are starting to fetch that. And over here, we don't need to call this function again. We need to put the found URL into the back of the queue, right? And we are going to do just that. So this queue is going to receive this link dot href. Perfect. Now let's try to run this. Okay, it is stuck. Actually, the reason for it is this guy over here, right? So this is not right. So you might like have spotted the issue, but if you're not, some people even ask this question over the interviews, why this might not be working. Is the reason is we are looping through, this is getting called asynchronously, or so this part needs to be called asynchronously, because this we are pushing links faster than ever we are visiting them, right? To fix that, we simply going to call this inside a concurrent function, and that should do it. And let's just call that. Perfect. So what is this over here? We'll just call this absolute URL. Okay, and we just pass it over here like this, right? And remove this guy. All right, so this is like a simple quick fix. And what we can do is, I think the fixed URL, we should fix it over here itself, right? And we can just remove this to fixed URL, and the base is the href, which is this guy. All right, makes sense. We have the absolute URL now, and so far it looks good. Just try to run this. Okay, it is going through. Okay, now what has happened is somehow I have just interrupted this. Somehow it went into JS, then it went over here, then it again came back to this js.org, and from here it went to Twitter, from Twitter it went to this guy, and so on and so forth. But if you look at this, we have some repeated URLs over here, right? To fix them, we need to have some kind of check where we need to have look that if this URL is visited, we don't visit that again. So we simply create another variable over here called has visited, or we can just simply call this as visited. All right, and visited is going to be a map of string and boolean. So let's just make a map which is going to be a string, has a key of string, and it is going to be it is going to have a value of boolean. All right, so visited is, I'll just call it has visited. Okay, so has visited. So we are going to do that check over here. Okay, and we'll just simply say if has not visited this particular href, okay, then only we call the crawl function, right? And inside this function, right, we'll just call that has visited map again. Over here we pass the href and we set it to true. Perfect. So let's see this in action again. Okay, it is going through. It is going to each and every pages now. Okay, it is now inside PayPal, going through. Okay, these are all the new URLs it is finding now. All right, so I'm going to stop over here by interrupting with the command C. So what I noticed was I just want to crawl the single domain. We can add that again with the if else condition over here. We can simply have a is same domain kind of a function. So what I mean by that is if the URL, the href that we are visiting is only from the js.org, then only we will visit that. Otherwise we won't crawl that. So we can do that check over here. It's up to you, completely option, but I'm just going to have that check over here. This is something additional, but I'll just quickly add that. So this is basically similar function to the fixed URL. So I've just went ahead and just already created the function and just going to paste it over here. So if you look at this function, it is almost identical to our fixed URL function. The only check it is doing over here is it is returning a boolean instead of a string, and that's it. So if URI host and parent URL host is same, we return false. If it is not the same, we return false. If it is same, we are just returning true, and we'll just do that. So additionally, and if is same domain, okay, so it needs an href and it needs the base URL. So the base URL is this argument, and which in this case now we'll need to store this as a base URL, and we just pass it initially over here and pass it over here as well. So we are going to visit only the URL from the same domain name. Let's try to do that. Let's check. Now in our case, we should not visit anything. So we should not be seeing anything related to GitHub or PayPal. Okay, this works. And these are the only URLs it has found. Let's try to visit another URL. YouTube maybe, yeah. This is going to be a long list because YouTube has many URLs. Yep. So this is working, and our application or our web crawler is working fine. And that's it from this video. If I have made any mistakes, any wrong information, please post it into the comments. And in the next video, we are going to learn or maybe solve a problem related to recursion. And after that, we'll jump into a few more Golang problems. And please don't forget to like and subscribe to my channel. Thank you. Bye-bye.